Hello, so worksheet 7a is our lesson on linear regression and linear models, and you're going to need a calculator in order to do this lesson. So preferably a TI-84, but if you have an 83, that'll do the trick. The directions that we give primarily are for TI-84s, and I'm going to be using specifically a TI-84 color edition. So if you don't have the access to that, but you do have a non-Apple product, like an Android phone or a tablet or just a regular computer that is not an Apple, you can download an emulator for free, and it's called Wabbit Emu, and it's wonderful because you can select even the same kind I use, the color screen edition, and I mean it has its limitations, but it does the job for our homework. So if you're ever at home and you don't have your own calculator and you don't want to buy one, that's a great option if you have the right sort of product and operating system. So we are going to have a lot of vocab today. And we're just going to dip our toes into this because you're going to discuss this much more when you get to a stats class. But if we have data that we can graph as a scatter plot, we can hopefully create a mathematical model. Now there's different types of models we can create, and the most basic one is going to be a linear model. But that would only be utilized if your data has a linear shape. So like we see here, the scatter plot looks pretty linear, but this one looks like a big blob of cloud. So we might determine that this data has really no relationship to each other, but this one is beautiful linear data. You're going to be able to calculate through the calculator today a correlation coefficient, which tells you how close it is to the prediction line that we're going to create, called the least squares regression line. And the correlation coefficient, which will be signified by R on your calculator, it closely resembles the slope when you're looking at linear correlation. So if you have a scatter plot that goes up like this, you're going to have a positive R because you have a positive slope, and if you have data that goes down like this, you'll have a negative R because you have a negative slope. The closer to 1 or positive 1, the better the correlation. So if it's an R value of like 0.99, that's a strong positive correlation. Same thing with negative 0.99, that's a strong negative correlation. So when we're in class, we're going to do an activity where I show you a couple of correlation examples, and then on the next slide, I have you kind of predict what you think the correlation coefficient is. And we're not going to go through these on this video, but like here I can see it's pretty tight, looks like a line. Not as good as this one, of course, but pretty good. And I see that it's negatively sloped. So maybe your friends would predict like negative 0.9 or something. And if we look, oh, it's exactly negative 0.9. Now in this one, it kind of looks negative, but it's not real tight in a line. So it's going to have a less good correlation coefficient. So maybe like a negative 0.6 or something. So it's actually negative 0.5, so pretty close. This is not a good correlation, by the way. Think of it like a grade. Ignore the negative sign, but think of it like a grade. You want like an A or a B, preferably an A. So anything in the A range is a good correlation, and the higher it goes up to 100% or negative, the better the correlation. This is terrible correlation. It's probably 0. I don't know. Let's look. Yep, 0. This is positive, but not real good, so I bet it's positive 0.5. Yep. And then, I don't know, positive 0.9? Yeah. And see how perfect this one is? It's completely linear, so that is a 100% or a 1 correlation coefficient. Okay, we are going to be using our calculators for a while here. So, on your calculator, we have some data that measures from year 1988 out to 1992 every year, and then cash flow per share for this company. And we don't want to use the number 1988 in our mathematical model because it creates ugly models. So they want you to let 1988 be year 0. So this is year 0. This is 1 year after that, so that's year 1. This is year 2, and 3, and 4. Now be careful, it's not always going to count up by 1s like we saw here. Sometimes it'll count by random increments, and sometimes it'll go by 5s. You just got to be real careful. So what we're going to do next is we are going to take care of our calculator in a minute. First, we have to turn on our diagnostics today. And if you never reset your calculator, you never have to do this ever again. So your diagnostics, the easiest way I think to turn them on is to go to what's called the catalog, which is a listing of every single command your calculator has. So if you go to the catalog, and then you scroll down until you hit diagnostics on. So it's alphabetical, so you can either scroll for a while, or let's see if mine actually pays attention this time. Alpha D. There we go. So at least I can jump down to the D's. I have a very bad lag on my emulator, so it's kind of annoying. There we go, diagnostics on. Hit enter twice to activate it. My diagnostics are now on. Okay, you don't want to have to do that ever again unless you accidentally reset your calculator. So next, you're going to need to go to Stat, and we're going to enter some data into our list. Now, I want to warn you, I've already entered the data for the next few problems because I don't want to take the time to enter them else, right now I'm trying to get ready for my next class, so I'm trying to go fast. So when we go to the edit screen on my computer, I have a bunch of data in here, but right here is the data that you guys need to enter for this question. So please pause the video and enter this data into, you can go ahead and keep it into list 1 and 2, or you could put it into list 3 and 4 like me, I don't care. But please pause the video and enter the data. So once you have your data entered, we're ready to do some calculations. But first, I'm going to check to see if this is even remotely linear. So we're going to go to our stat plot menu. So second y equals, and then I'm going to open up plot 1, and I'm going to turn it on, which mine already was, and I'm going to choose the scatter plot. Now remember, my data was in list 3 and list 4, so I'm going to go down here and change this to list 3. List 3 is typed right above 3 in blue, so I'm going to do shift list 3, and then same thing with list 4, except that's under the 4, I'm guessing. So second, list 4. You can choose whatever marker you want, whatever color you want. Now before I actually look at the scatter plot, I haven't set up the window. You can go ahead to window and adjust it so it's appropriate. Or another kind of trick that I usually use first and see if it works, I always go to Zoom and Stat. Remember, Zoom is your pre-programmed window, a menu of windows that often work for different types of questions. So if you're doing statistics, Zoom Stats is usually a good option. So I'm going to choose Zoom 9 and see, oh, that's beautiful. So that scatter plot is super linear. This is an awesome linear correlation. So they want you to draw that on your paper, so please do that. Then they want you to go back excuse me, and mention what the correlation is. We're going to actually calculate the correlation in a second, but I can tell that this is a strong positive correlation. So we're going to write all those things down, and I'm going to kind of cheat because I don't draw well on a good day, and I'm too tired to consider this a good day. So this is a strong positive correlation, and when you were plotting these, it was, something like this. So now for the good stuff. I'm actually going to let you calculate it. We can write an equation by hand using 2 years, and it could be any 2 years. Oh, and we actually do want to do that, so I guess, bummer. We're going to go ahead and do this one problem. You know what? That's going to allow me to skip the next problem, so that's exciting. Letting year 0 be 1988. Remember, this was 0. So I'm going to use this ordered pair right here. So 0, 2.38. And then the year 1990, which was year 2, right? So this ordered pair would be 2, 3.23. So first thing I'd have to do is calculate slope, which would be y2 minus y1 over x2 minus x1. And you know what? I haven't actually done this yet. So let me get a little calculator help. 2.38. Oh, come on. 3.23. It's a little tedious to type on. I apologize. 2.38. So that's the change in y, and then it was divided by 2. So our slope, which a decimal makes sense, 0.425. I'm going to write that down. And it's kind of cool because I don't have to do any more calculation. This was the y-intercept because the x value is 0. So when I go to create my line, y equals 0.425 x plus 2.38. That is the linear equation when calculating by hand. So now what we're going to do next on the next side, we're going to use our calculator to come up with that line, and let's compare them and see how close it was. I'm sure you won't be surprised to hear that the calculator does a better job. Okay, first, I want you to, let's see, this lesson is going to be very specific to the TI-83Cs. It's very close to the older calculators as well. Just the newer calculators have a couple of extra things for you to fill out or possibly skip over. So if you don't see part of the menu there because you're on an older calculator, that is okay. Oopsies, totally wrong thing. Here we go. So on my calculator, on your calculator, I want you to go to Stat. We've already put in data into our list, but now we're going to calculate something. So go over to Calculate, and then choose number 4, which is linear regression. So on the newer calculators, it asks you who is your x and who is your y. Remember, I did list 3 and list 4, so I'm going to have to type those and change them to list 3 and list 4. If you do not have that, that's fine. If you're on an older calculator, you're going to have to type list 3, comma, list 4 after the command. Frequency list we're not going to use today. That would just be if you had a tally chart where you had so many things show up so many times, so they shortened the table by putting a tally table in. And then store, I love storing the equation into y1, and I want you to get used to doing this, so let's do that. While you're sitting in store reg equation, hit the varies key, which is right here. Go over to where it says y varies, and we are graphing a function. So choose that, and I would like to place this in y1. Alright, once you're ready to go, hit calculate, and it's going to pop out a bunch of info. So y equals ax plus b, where a is the slope and b is your y-intercept. So, on my paper I need to write down my formula, which is y equals 0.421x plus 2.378. And then this number right here, just the r, not the r squared, this is your correlation coefficient. So yeah, that has a very strong positive correlation. So that's why we saw such a linear relationship between those data points. Alright, moving all this info over to my paper here. I already forgot it. 0.421x, I think. Let's see. Yep. Plus 2.378. And if I go back and compare that to our hand calculation, 0.425 and 238, you know what? Pretty darn close. And that's because it has such a high positive correlation there that we can calculate that. The correlation coefficient is 0.999. So very, very strong positive. Alright, we already learned how to store it. Go us. We're good. We can skip that. And I think we already did all that. So here's you can pause the video and read these over if you're having any sort of issues. Remember, on the older calculators, the menus don't quite look the same. Okay, great. So then the next question. We already had this, right? 0.421 x plus 2.378. So they want me to use my line to predict. And I'm going to show you, there's a bunch of ways we can get these answers, but I'm going to show you what I think is the best way and the way that we're going to use in the future. So let's go ahead and do it. Predict for the year 2000. Well, if this is year 0, the year 2000 would be 12 years after that. So I need you to either plug in 12 manually, or I'm going to show you a little bit of a shortcut. Your calculator can do all that for you. Once you have it set up, that is. So we're going to use our table feature, and we're going to set it up so I don't have to mess around with this again. So go to second window, which is table setup, and then choose for independent variable, put that in what we call ask mode, and put the dependent variable into auto mode. That means you're going to fill in x's and it's going to spit out the y's for you. So to our table. They wanted year 12, so I type 12, enter, boom, there's your answer. I think the next question asks you for year 2014, which would be 26, right? So, and what was this, 743? So when I type 26 into my x and hit enter for the table, I get 13 point something, and remember it's money, so it makes sense to round to 13.32. So that is a more effective way to find answers, because if you have a really funky equation with lots of rounding, your calculator's stored equation is not rounded at all, so it's going to give you the best answer. And when we get into more complicated math later, you're going to want to use that every single time. Alright, I'm going to skip this question, because we already did one by hand, and that was good enough for me. Alright, let's go to this question. We have an experiment to determine if there's a relationship between the number of television hours watched and the average number of books a person reads, a student reads. So use linear regression feature on your calculator to form the equation like this. Now pay very careful attention to this equation, because b is the dependent variable and h is the independent variable. So for most kids, they don't really read through anything, and they go ahead and they put this into list 1 and this into list 2, which is fine. If you did that already, I'm not going to tell you you're wrong. Let's look at what I did. So it looks like I did the reverse, and I'll tell you why. So if it says b equals, that's kind of like your y, isn't it? So this is really like your y part of the table, and this is really like the x part of your table, so these are kind of flip-flopped. So when I went to the stat edit, so I went to stat and then edit, and I already had these programmed in because I didn't want to waste time, I put them in that order for list 1 and list 2. So I'm going to use this as my x and this as my y. If you did something else, it's okay. So I want to go find the linear regression equation. Remember, we went to stat, this time over to calc. My data for x, here, choose 4. My data for x was in list 1, and my data for y was in list 2. I would like to store my equation into y1. So for store, we're going to go to varies, over to y varies, and then function. Oh. Alright, command it to calculate, and then we'll have some information we're going to jot down. So here's the information for the equation. You can also find it over here in y1 because we made it store, but it's a little hard to read. See how it doesn't like really truncate decimals? But let's quit out of there. Oh man. Okay. There we go. The correlation coefficient is negative 0.987. That's very strong negative correlation. And if I look at zoom stat, so zoom 9, I gotta redo the window. You know what's wrong, guys? I didn't change my plot. Remember how I had my plot going list 3, list 4? Well, now I gotta do list 1, list 2. Alright, list 1, list 2. And then I do have to go back through zoom. It reconfigures the window when you do this. So zoom 9, there you go. Pretty good fit. I mean, the points aren't dead on the line, but they're close. So write down the equation, and then it says if no books are read, what are the hours of TV that were watched? So remember that table we had set up beautifully? Well, no books are being read. Oh, that's not what I wanted. Remember what X stood for? X was the hours. Haha, never mind. Get out of here, Abruzzo. Alright, let me go back and write down our equation. Y equals, which is really B equals negative 1.607x plus 6.277. So no books, meaning we're going to plug in a 0 right there for B. So I'm going to do this on paper actually. 0 equals negative 1.607x plus 6.277. And if I solved this, I'd have to type on my calculator like negative 6.277 over negative 1.607. Comes out to 3.9 hours of TV. I already calculated that earlier. I apologize. Find the correlation coefficient. We already did. That was a negative 0.987 when you round. If it doesn't say where to round, rule of thumb for these would be the thousandths place if that's appropriate. Okay. The data on the next question is not entered for me. So, we're going to have to pause the video, so will you? Year 94, and we're going to want to start our model at some point. You can technically start it wherever you want, but for most kids, they start the first year as year 0. And then I notice they're counting up by ones after that. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, in your calculator, I need you to enter the year into list 1, or somewhere, and then the consumption into list 2. Pause your video, get your data entered. So I went ahead and put my data into list 5 and 6 because I didn't want to delete my old data so I could keep using it for the next class. Sorry, lazy. I just have to remember that that's where it's at. So we're going to find our linear regression equation by going to calculate and then linear regression. So definitely not in list 1 anymore. That was list 5 and list 6. I would like to store my equation into y1 again. You could technically store it anywhere, but remember we already have that old equation. Oops, we already have that old equation in y1, so I'd like to overtype that. All right. Boom. Lovely. All right. So there he is. Oh, I shouldn't have done that. There we go. So it's going to ask us to write down the model, which of course we will. And then I notice the correlation is really good, so let's go ahead and use that model to predict the consumption in the year 2008. So if I think about, okay, where are we at in the year 2008? That would be, remember our model started in 94. So, I guess they do want correlation coefficient. Let's write this all down. 2.209x plus 113.318. Correlation coefficient is, oh snap, I didn't write that down. 0.997 if we round. So 2008 would be 14 years later, right? So that would be where x equals 14. I'm going to go to my table since it's set up to do this, I think. Oops, table. And predict the year 14. 144.25. Okay. So it doesn't say where to round. And what are we actually measuring here? Gasoline consumption data in billions of gallons. So I'll just write down the exact number we got, which I already forgot what it was. It was 144.25. Yeah. Oh, lordy. 144.25. Awesome. Billion gallons of gasoline is predicted for the year 2008. Okay. There's our lesson. I know we skipped that one problem by hand. We'll probably do it in class, but, you know, whatever. All right, good luck. Remember, you do need a graphing calculator to do these, and the more you practice, the more muscle memory you're going to develop, and the easier this will become. This is not the last time we do regression. We're going to do all sorts of different types of modeling, so this is not something that's going to go away. We're going to use a lot. So make sure if you have any questions, you come back and see me.